Here's the 11-4 part 2 of the conditional probability section, and we're going to start by exploring the formula. So we already talked about the notation for this part right here. Again, that is read the probability that event B will occur given that A has already occurred. So in order to calculate that, we can use this formula where our numerator is made up of the probability of A and B happening over just the probability of A happening. So this means that we can calculate conditional probability given other probabilities. So let's see how that looks from a two-way frequency table. Okay, so we have this two-way frequency table from page 698, number 3. Okay, and it's talking about researchers who asked people, I don't know why they would ask this, but they asked shampoo users whether they apply shampoo directly to the head or into their hands first. So we see the table, right? You're either male or female, so they're asking your gender, and then they ask you directly onto the head or into the hand first. The question that they want to answer is, what is the probability that a respondent applies shampoo directly to the head given that the respondent is female? Okay, so first let's try to write this as a probability. So what may happen? What are we trying to figure out if it can happen? Well, that's applies shampoo directly to the head given that the respondent is female. Okay. All right, so how does this work with the formula? Well, my numerator is made up of the probability that they apply directly to the head and are female over the probability that they are female. Okay, so we actually have two different probabilities to calculate here before we can calculate the overall probability. So what is the probability that you apply to your head and are female? Okay, well, to do this, we need all our totals. So let's add all the columns up to make this easier for ourselves. So 2 plus 6 is 8 people who apply directly onto the head. 18 plus 24 are 42 people who go into the hand first. There are 2 plus 18, 20 males. 6 plus 24, 30 females. And if you add them all together, there are 50 total participants. Okay, so what is the probability that you apply to the head and are female? Well, that is represented by this box right here, right? Female and applying directly to the head, out of a total of 50 participants. So 6 divided by 50 is equal to 0.12, a terminating decimal, so I can leave it that way. Okay, so that's going to be my numerator, 0.12. Now we need the probability that somebody is female. Okay, well, we go to our female row. There's a total of 30 females out of 50 participants. We plug that into our calculator and we get 0.6. That's going to be my denominator. So if I type that into my calculator, 0.12 over 0.6, I get 0.2 as my probability that we apply to the head given that we are female. Now, that seems like a lot of work because we probably could have just looked at the table, right, and figured out what is the probability? Well, the number of females that apply directly to the head over the total number of females altogether. Both will give me that 0.02, but I really wanted to demonstrate the use of this formula because we may not always have a two-way frequency table. So that's what my next example is. What happens when we don't have a two-way frequency table? How do we calculate? Okay, so we're going to use this formula, and we're going to look at page 700, number 17. So we're given some information. 39% have a pet now and have had a pet. 61% do not have a pet now, 86% have had a pet, and 14% do not have a pet now and have never had a pet. We are being asked to find the probability that a respondent has never had a pet, given that the respondent does not have a pet now. So how do we write this as a probability statement? Well, the probability of what may happen, which is never had a pet, given that they do not have a pet now. Okay, probability never had a pet given that they do not have a pet now. So according to the formula, right, we need the probability of A and B. So the probability that they never had a pet and don't have one now, over the probability of just A, which is the second value. So the probability that they do not have a pet now. Okay, so let's take a look. Where do we have never had a pet and do not have a pet now? 14%. And what percent do not have it now? 61%. Okay, so 14 over 61 gives me approximately 0.229, which is about 23% if you're asked to round. Or you can leave it as the fraction 14 over 61 because that does not reduce. Okay. So now I'm going to ask that you pause the video and try number 21 on page 701. It states that a math teacher gives her class 2 tests. 60% of the class passes both tests, and 80% of the class passes the first test. What percent of those who pass the first test also pass the second test? So I'm asking you here to write a probability statement and to use the formula to find the probability. When you are done, unpause and I can show you the answer. Okay, hopefully you had some time to figure this out. So the first thing you needed to do was to figure out what our statement is. So what are we trying to figure out the probability of? What has already happened? So if we look at the question, it says, what percent of those who pass the first test also pass the second test? Well, it doesn't say the word given, but it does say what percent of those who passed the first test. So if you see that what percent of, that's kind of telling you what is the total number of people you're putting in your denominator. What is that bigger group, the larger group? Well, that larger group is those who have passed the first test. So the value or the statement that goes after the given is passed the first test. So what are we trying to find the probability of? Well, we're trying to find the probability of those who pass the first test that will also pass the second test. Okay, so that's the big question mark. Who will also pass the second test? Making the pass the second test the first part. So if I was going to read this probability, I would say find the probability that someone passes the second test given that they have passed the first test. Okay, so now we use the formula, right? The probability of A and B over the probability of A. So we have to find the probability that you've passed the second test and passed the first test over the probability that you have passed the first test. So if we look in our question, choose a different color, 60% of the class passed both tests. So that satisfies passed second and first. That is my numerator. Then it says 80% of the class passed the first test. That satisfies my denominator. When I reduce it, I find that that becomes 3 over 4, which is 75%. Okay, 75%. Okay, when you have watched this video and you feel comfortable, I'm going to ask that you attempt this exit ticket and submit it to Edmodo. It is found on page 700, number 4. It states that the probability that a car has 2 doors, given that it is red, is 0.6. The probability that a car has 2 doors and is red is 0.2. What is the probability that a car is red?